This brings us to a species with which we are more familiar, Homo sapiens, who began about 200,000 years ago and today are the only surviving human species on Earth. Beginning in Africa as an offshoot of Homo heidelbergensis, Homo sapiens slowly began to populate the early entire globe. During a time of dramatic climate change 200,000 years ago, Homo sapiens began in Africa. Like other early humans living at this time, they gathered and hunted food and developed behaviors that helped them respond to the challenges of survival in unstable environments. Anatomically, modern humans can generally be characterized by the lighter build of their skeletons compared to earlier humans. Modern humans have very large brains which vary in size from population to population and between males and females, but the average size is approximately 1,300 cubic centimeters. Housing this big brain involved the reorganization of the skull into what is thought of as modern, a thin-walled, high-vaulted skull with a flat and near vertical forehead. Modern human faces also show reduced brow ridges. Jaws are also less prominent, with smaller teeth. Although earlier waves of humans ventured north in pursuit of animal herds during the warm interglacial periods, the last wave from one branch is dated to 60,000 years ago. The out-of-Africa theory is the most widely accepted model of the geographic origin and early migration of anatomically modern humans. The theory was speculative until the 1980s, when it was corroborated by a study of present-day mitochondrial DNA, combined with evidence based on physical anthropology of archaic specimens. Genetic studies and fossil evidence show that archaic Homo sapiens evolved to anatomically modern humans solely in Africa. Over time, these human species replaced earlier human populations of Neanderthals and Homo erectus. The date of the earliest successful migration out of Africa has generally been placed at 60,000 years, as suggested by genetics, although earlier migrations out of the continent may have taken place as early as 125,000 years ago. In 1987, a worldwide survey of human mitochondrial DNA was published. The main point was that all mitochondrial DNAs stem from one woman, and that she probably lived around 200,000 years ago in East Africa. When the media picked up the story that they had found the mitochondrial Eve, or African Eve, the story became a sensation. Unlike nuclear DNA, mitochondrial DNA comes only from the mother, and all living humans are thought to be derived initially from a single woman. Mitochondrial DNA is transferred from mother to daughter, generation after generation. In the field of human genetics, the name mitochondrial Eve refers to the matrilineal most recent common ancestor of all currently living anatomically modern humans. This is the most recent woman from whom all living humans today are descended on their mother's side, and through the mothers of those mothers, and so on, going back until all lines converge on one person, ancestral to all. Mitochondrial Eve was not the only living human female living at that time. However, her female contemporaries did not produce a direct, unbroken female line to any woman living today. Mitochondrial Eve lived later than Homo heidelbergensis and the emergence of the Neanderthals, but earlier than the out-of-Africa migration. On the male side, we have a counterpart dubbed Y chromosome Adam. All men living today would theoretically have a Y chromosome descended from one man to whom all men would be related. According to new research reported in the European Journal of Human Genetics, our most recent common ancestor, the so-called Y chromosomal Adam, lived on the Earth over 208,000 years ago. Even though it is possible both of our ultimate parents could have lived during the same time frame in Africa, the idea they might have known each other romantically is highly problematical. More recent studies from Neanderthals and from human specimens found in a Denisova cave in Siberia have given our understanding of our ancient past an unexpected turn. They indicate that modern humans did not completely replace other human species as had once been believed. Instead, there was some interbreeding taking place between different human species. This idea has become known as replacement hybridization, or leaky replacement, or mostly out of Africa. Whole genome sequencing of African hunter-gatherers suggests that modern humans in Africa may have bred with archaic populations that were still in residence at the time. So although most of the modern human genome originated in Africa, some genomic regions possess older lineages. In other words, there appears to be overlap among human species instead of a nice, neat, straight line from Erectus to Heidelbergensis to Homo sapiens, as we see on most charts of human lineage. Ancestry appears to be a little more messy than what has been popularly believed, according to the most recent studies. Oh, and don't forget to hug your own little Homo sapiens tonight. After all, they have come a long way. In the next episode, we'll begin to tackle Genesis 2 and see where biblical Adam fits in the anthropological picture. We will see that the Genesis narrative is quite compatible with all we have discussed up until now and with the history of the ancient Near East, beginning about 7,000 years ago. And thank you for watching.